finding, I said back left corner, top left corner, however you want to call it, that corner right there, your X has to be, my stuff's wrong already. So I'm going to select my Z axis to change that, okay? X, Y, and Z, just like that. If your Z's down, it's no good. If your Y's the other way, it's no good. It's got to be like that, okay? It's important. So that's pretty much the end of my setup. You can mess with your program over here already, but I'm not going to take you guys into that. I'm going to show you how I do it once I actually hit post the program, okay? But you can go ahead and actually set that up. But anyway, we're going to hit OK. So now my setup's done. Now I'm going to go ahead and drill the hole first. So what I'm going to do here is we're just going to go over here to drill. We got to have a tool. If you guys don't have tools, you can create tools. Titan will automatically pull tools for you guys. He's got a tool list is what I'm saying. There's me a 1/4 inch drill bit right there. That's fine with me. So I'm going to select that tool. We're doing the hole, okay? 4,000 RPM's fine. Speeds and feeds, I'm really not going to get into. There's a lot of different things out there on Google to tell you guys about speeds and feeds, but they are super important. That comes down to time management because you got so many manufacturing companies out there competing against each other. Time is key. Okay, so the least amount of time I can do a part and still get it accurate, that company's probably going to come to me, and it's going to be better for my company because I can run 7 times the amount of parts another company can. Okay, but you can only push tooling so much. Okay, tooling is the one thing that wears out the most, and tooling's expensive. I told y'all yesterday, just a 1/2 inch carbide end mill is $150. Okay, so it does get really expensive. So we got our coolant on. This is plunge feed rate, 18 inches a minute is fine. Geometry, we're going to select our hole. Now, this is the, not worried about none of that. This is the most important thing right here, is your heights, okay? This is where people mess up, programmers mess up, setup people, because in manufacturing environments, you have a programmer, and then you have a CNC setup person, and then you have a CNC operator. So, the programmer gives the program to his CNC setup person. Here's my program on my thumb drive. Please go set this machine up. CNC setup man's gonna say okay. Well, if the programmer come off the bottom of the part instead of the top of the part, and the CNC setup person didn't know that, they just wrecked the machine. They wrecked the tool, okay? So that's why it's important. So what I automatically like to do, and you can set these, I haven't, but as I like to just go ahead and go model top on everything, just because it's easier. Now, we're drilling a hole, so I'm gonna leave hole top and hole bottom, okay? On my top height and my bottom height. My feed height, it's gonna say, okay, I'm coming down 200 thousandths above the part, and that's where I'm gonna start feeding at. My retract height, I'm gonna come up 200 thousandths above the part. My clearance height, whenever I get done drilling, I'm going to 400 thousandths above the part. Okay? Makes sense? Mm-hmm. Am I going too fast? All right. So, hole top is my top height, and that's what I want because I'm going to touch right on top of the part, the model. Hole bottom is fine because that is my bottom height. Now, I'm going to say drill tip through bottom. How much do I want to go through? There's a calculation for this, but we're just going to go 150 thousandths, okay? So 0.150. Drilling, wrap it out. You can do a lot of different things here. You can do chip breaker, partial retract, counterbore, dwell. What a dwell is it stays in the bottom of the hole for a minute. There's a lot of different options you can do here. I think drilling, wrap it out is fine. We might come back and make it chip breaking. So then we're just going to press OK. And there's my tool on my machine coming in. We're gonna simulate that. Simulation is very, very important in machining because I can slow my speed down. I can go to my info, gonna watch my Z. That's the biggest thing. So it's gonna come in and it's gonna drill. I really don't like that. I really wanna peck it. And what a peck is, I want it to go, okay? The reason why I wanna peck it is because it's only a 1/4 inch drill bit. It can walk, okay? We're not gonna do any center drilling or anything like that. I got a 1/4 inch stub drill out there, which is a little bit shorter drill bit, so it doesn't walk as much. So we're gonna try to take that cycle of center drilling out. You see what I'm saying? We're gonna save a little time there, you know what I mean? Okay? So we're gonna go chip breaking, partial retract, by pecking depth, 63. We're gonna go 100 at a time. And the rest of that is fine. I really don't want to put a dwell on it, it's fine. So now you're gonna see the difference, okay? We'll zoom in a little bit so you guys can see it. Go back to my info. Well, it was supposed to retract. I don't know why it did not retract. Hold on.
Tapping with chip breaking.
I'll try that one. I think I can get it. There we go. Okay. See the difference?
Mm-hmm.
Okay, so that's fine. We're gonna leave that alone. And then, the last thing is we're gonna do the Viking part. Okay, so we're gonna go to 2D. You can go to engrave. We're not facing anything. And we're gonna actually leave the stock alone and leave the scale that different. The aluminum out there that looks a little different on the top. And like once you guys cut it on the side, you saw the difference, right? Between the surface finishes. That is called scale, okay? Remember that. We're not gonna knock the scale off this time. So we're gonna select our tool. And if you guys need these tools, that's fine. 1/4 inch chamfer mill's fine. I got these tools saved on a thumb drive. So this is all your machining information. Spindle speed, 4,000 RPMs. That's what we're gonna run. Service speed, I'm not really worried about. The biggest thing you want to look at is your cutting feed rate and your spindle speed. 20 inches a minute's great. Geometry. Now, remember how I said, see all them little things?
Mm-hmm.
So in order for this image to look right, and I'm sure I could clean it up some kind of way in Inkscape, but in order for this image to look right, I got to go in and select all of that. So that's what I was talking about the other day whenever I said all your detail. And it's fine if you want to go in here and select all these little pieces, okay? For this, I'll cancel that. I'm going to engrave. I'm just giving you guys a little example today. I'm not going to take that much time and select every one of them, so I'm just gonna do the bigger pieces outside here, and I'm gonna roll with that, okay? But if you really wanted it full detail, you need to select every one of them little bitty lines.
Can you not highlight them all at once?
Nope, not that I know of. Not that I know of. I've looked up videos on it, and I cannot do it. So, that'll be a good thing for you to figure out for me, Matthew. So, another thing. What? You gotta ask Mr. Bates. Okay, so. Same thing again. We're gonna go model top, model top, model top, all the way down. Model top and model top. So, engraving, it says 118 thousandths. You're never gonna engrave that deep. Okay, never. The most you're ever gonna go is about 20, okay? It's not very deep because the deeper you go, the more messed up it looks, okay? So we got that done. Now we're gonna press OK. And then my engraving tool is gonna come in and engrave what I selected. Okay?
Alright, let's go make it.
So that's what it would look like on the machine. So, we're not ready yet. So, we're gonna exit. Now, tool numbers. Remember yesterday how I explained y'all T1, T2, T3, right? We're gonna make the drill our tool 2. So there's a couple ways you can do this. The quickest way for me to do this is edit tool, go to post processor, and click down to 2. Okay, that's gonna change my tool number to 2. My length offset, remember the H I was telling y'all about? That's super important. And then my diameter offset, okay? Super, super important. We're gonna accept that. Be sure they match. The engrave, we'll make it tool 3. Okay? Accept. So now I got tool 2, tool 3. Got my drill, got my engrave. Now, if I highlight this is important too. I've done this a couple times, and you guys may know this. I don't know. But and I hit post process with that highlighted, that's the only process it's going to post. It's the only G code you're going to get. So be sure you highlight the setup whenever you do this. So, post processor. This is where you give your program a name / number. That is the name. I'm just going to say, usually it's 5 numbers. Let's just say 1, 2, 3, 4, 5. We're going to give it a comment. I'm going to say, Kody, keychain, if I can type today, Viking. Okay? Your machine is super important. There's a whole bunch of machines on here. Okay, we're running the Haas pre-NGC. Now, that one is a UMC 750. So that's a 5-axis machine. That is not going to work. Okay, the reason why it's not going to work is because my machine out there is going to say, I'm trying to 0 B-axis. Well, a B is what a B-axis spins this way, okay? All we have is X, Y, and Z, so that selection will not work. So what I do is I go to Haas pre-GNC, and you can look over here. It used to tell you 3-axis. It says capability. It might be in an update, but anyway, you just want the Haas pre-NGC that says mini mill series, okay? We're going to select that. And then you can have that here, okay? So all that's done. Now, you guys are going to have a built-in setting. Hey, it did it for me. Built-in high feed rate, 500. That machine out there will not run 500 inches a minute in high feed rate. It's a little bit older, okay? The newer machines Haas makes will run the 500 built-in feed rate. Mine will not, so you have to change this. I change it to 100, okay? It will run a little bit faster than that. Just change it to 100. Be sure you do that, because if you do not, it's going to alarm out there. We're going to have to go back to the computer and change it, okay? And then you just simply click post. And then I hit view NC code. And there's my G code right there. It tells you drill, Kody keychain Viking, my number. All programs start with a %sign. Tells you my tools. Hey, tool 2 is a 1/4 inch. Drill, tool 3 is a 1/4 inch chamfer mill. G90 stands for absolute programming. G17, I gotta look at my book. Okay. So, the rest of these, this is inches, I believe. This is a work coordinate system. So, I gotta look at all that. I don't know all these codes off the top of my head. Nobody does, okay? If you do, you're a bad son of a gun. But anyway, Tool 2, M6. I told y'all yesterday, that stands for Tool 2. Change to Tool 2. S4000, M3 is what? Engineer student.
Spindle speed.
Spindle speed 4,000 RPMs, and what's the M3 stand for?
Clockwise.
Clockwise rotation. G54 is my XYZ0 location. Okay? And then there's my M8 stands for coolant on, M9 stands for coolant off. There's my X and Y location. Then it's going to change to Tool 3. I was looking for the H. There's my H. Remember how I said your H has to match your number? Right? Your H is your height offset. Super important. Because if that was a 3 and I got Tool 2 in the spindle, it's going to read the 3rd height offset in the machine simulator. Okay? And that's how you wreck a lot of things. That's why I told you it's important those numbers match. Okay? And there's all my code just for that little bit of the Viking that I selected. I didn't even select it all. Okay?
So it's your birthday?
And then there's the end of my program. Alright? So then, once you do that, we're going to file save. Close that out. Go here. I did not bring a USB in here. Everybody know how to load this on a USB?